Hello everyone, I'm Lee. In this video, we are going to talk more about array and pointers and their relationship. So let's take a look at this function array and pointer. So I declare a static array now, and one thing I want to point out and is int array is a pointer to the first integer of this array. So it contains the address of the first integer of the array. So when I try to dereference this one and give it 1, that means I set the first element of the array with 1. And this notation, we know it all the way. So it's a bracket 1. That means I'm trying to access the second element of the array. It's called subscript operator, the bracket operator of the array. And this one, we're using pointer arithmetic. Int array plus 2 isn't a normal arithmetic. This plus operator is overloaded. That means it has multiple meanings, depends on what kind of operand does it get. So in this case, one operand of the plus operator is a pointer. Then it's going to do pointer arithmetic. Pointer arithmetic means it will do int array plus 2 multiplied by the size of the element in the array. In this case, it will be the size of int. That means it will add 2 multiplied by size of int. So you move down the pointer to the third element of the array, then you dereference it. That's 3. So this is the same as this guy. And actually, what's behind the scene of this subscript operator is this. Okay, and now another operator I want you guys to pay attention to is the size of operator. Here I say size of int array, so it gives me the size of the array and divide by size of int. I got how many elements are there in the array. This is size of the array by byte, and do the division, you got it. Okay, so and the next function is more about the pointers. More about pointers, let's take a look at this declaration. Array of pointers, so read it this way. It's a pointer to a pointer of address entry. So array of pointer is a pointer to a pointer of address entry. Let's take a look. So array of pointers, I create a dynamic array, and the individual element of this array is pointer to an address entry object. So it's not an array of address entry object, it's an array of pointers to address entry objects. Actually, this is common practice. For our previous sample code, what we did is we put address entry object directly in the array or in the linked list. Usually that's not the case. Usually we put pointers of the object in the array or in the linked list. The reason are, one, it's easy for data sharing. If you have two different data structures, they want to share the same data. If you put a pointer there, it's easy to do that. And another one is it's easy to manipulate pointers than the actual object. Imagine this: if we're trying to sort the array, so we're going to swapping the elements, move the elements around. If you're moving objects around, that's more expensive operation. But if you're moving pointers around, they're just 4 bytes address lots of the time, so it's easier. So this is actually common. So now we're creating an array of pointers to address entry objects. This is how we do this. And here we populate the array, then print array, then release the array. And before we are done, we delete this array of pointers so that we don't have a memory leak. Now let's take a look at how to populate this array. So remember, this is an array of address entry pointers. So we go through the array, and for individual element we create the address entry. So you see the element of the array is actually just the address of the object. So you can use real data. You can read it from a database file, then do it, but we are not doing it here. We just use a default constructor. And how to print the array? Very similarly, you go through the array, but individual element of the array is a pointer. So if you want to invoke the member function print, you have to use this big arrow instead of the dot, the member access function. And another one, how to release the array. Remember, you allocate all the objects dynamically, so you have to loop through and delete. You're not deleting the pointer, you're deleting the object pointed to by this pointer. You loop through, delete each objects there. And when you do this delete, the destructor for address entry got invoked. Okay, and the last one we are going to talk about is array of arrays. So let's take a look at this one. So int table is going to be a pointer to an int pointer. So let's see. We first create the array, new int pointer. That individual element of the array is going to be a pointer to integer. So this is the array. And then we go through this array and allocate an int array for individual element of that array. So now we create another dimension here. So we loop through this array for each pointer. We create a new int array and store that address in that element of the array. And now we are trying to populate the table. So the two-dimensional array, we first loop through individual row, and for each row itself is an array, so we loop through and populate. And similarly, when we try to display the table, we loop through each row, but for each row itself it's an integer array. We go ahead and do the display. And after we're done, we need to deallocate the release memory here. So loop through the two-dimensional array, and I think I forgot something. I should deallocate this guy as well. So otherwise we got memory leak. So we need to delete int table. Thank you.